Production of dairy products using enzymes. The importance of dairy products. Milk and dairy contain many nutrients, which are important in a healthy, balanced diet. Some are calcium, which is used for healthy bones and teeth, phosphorus for energy release, magnesium for muscle function, protein for growth and repair, vitamin B12 for production of healthy cells, and much more. Production of dairy products. To make different dairy products, the production processes are not the same and require different steps. Some enzymes are required for the production of cheeses, yogurt, and other dairy products, while others are used in a more specialized fashion to improve texture or flavor. For milk, the production process is 1. Cows grazing. Cows feed off fresh grass after milking. Also, they may be fed some grain and hay silage. Silage is grass or other green fodder compacted and stored in airtight conditions. They only feed off of it if there is not enough grass available. 2. Harvesting milk. Machines milk the cows, and the milking machines mimic the action of a young calf by creating a pulsating vacuum around the teat, which causes the milk to be released from the udder. 3. Storing milk. Milk is stored in vats or silos which are refrigerated. Milk is stored at 4 degrees Celsius and less for no longer than 48 hours, so milk fat does not separate from the milk. Transporting milk. The tankers that are used have special stainless steel bodies which are heavily insulated to keep the milk cold during transportation. 5. Laboratory testing. Samples of milk are taken from farm vats prior to collection and from bulk milk tanker on arrival at the factory. Samples are tested for antibiotic and temperature before the milk enters the factory processing area. It's also tested for milk samples for milk fat, protein, bulk milk cell count, and bacteria count. If milk is unsuitable for quality products, the milk will be rejected. Processing milk. Whole milk, once approved, undergoes pasteurization, homogenization, and further processing. Pasteurization is heating every particle of milk to a specific temperature for a certain amount of time and cooling it again. The reason for this is first off to ensure all milk products are safe for human consumption by destroying all bacteria that may be harmful to health. Example, pathogens. Homogenization involves pushing milk through an atomizer to form tiny particles so the fat is dispersed evenly throughout the milk, stopping the fat from flowing to the top of the container. Further processing includes reducing the fat content, increasing storage life by high temperature treatment, or culturing milk for flavored and yogurt products. This is where enzymes are involved to change some characteristics of milk, such as taste, storage life, intake, consistency, and more. Here is a video demonstrating enzymes being used with milk, more specifically lactase.
Lactose is a disaccharide sugar found in milk, and it's made up of 2 monosaccharides, glucose and galactose. Lactose can be broken down into glucose and galactose by the use of the enzyme lactase. The glucose and galactose produced is then absorbed into the bloodstream via the small intestine. Now, almost all humans have the ability to digest lactose because they produce the enzyme lactase in their digestive tract. However, it is possible for them to lose this ability over time and not produce as much lactase, and these people are known as being lactose intolerant. People who are lactose intolerant often suffer from cramping, excess gas, and diarrhea as a result of the fact that bacteria in their digestive system feed on the lactose that's not broken down. Another organism that often suffers from lactose intolerance is cats, as a result of the fact that after weaning, their production of lactase decreases dramatically. However, it is possible to produce lactose-free milk by using the lactase enzyme to break down the lactose in the milk. Here I'll show you how this can be done in the lab using milk containing lactose, calcium chloride, and a mixture of sodium alginate and the lactase enzyme. The sodium alginate containing the lactase enzyme is added to the calcium chloride. This forms small beads in which the lactase enzyme is immobilized. After being allowed to harden for a few minutes, a tea strainer can be used to separate the small beads from the calcium chloride solution. The following equipment is then used to bring the lactase beads in contact with the milk. So we'll have a syringe, some tubing attached to that syringe with a clamp on it, and some gauze at the bottom of the syringe to prevent the beads from getting stuck. The immobilized lactase beads are then placed inside the syringe. The milk containing the lactose that you wish to break down is then added over the immobilized lactase beads. After the milk containing the lactose has been left in contact with the lactase enzyme for 2 minutes, the milk is cycled through the syringe. The glucose concentration of the milk is then tested. Here you can see that after the first cycling, the glucose concentration is reading negative or no glucose. So what we do is we pour the milk back into the syringe to allow it to have further time in contact with the lactase enzyme, and we'll leave it there for another 2 minutes. After the second cycling, you can see that the glucose concentration has increased. This entire process is repeated, testing the glucose concentration of the milk at the end of each cycling. Each time the milk is cycled, which means that the lactose in the milk has more time to spend in contact with the lactase, the glucose concentration of the milk increases. This is because the immobilized lactase enzyme has broken down the lactose in the milk into glucose and galactose. This same process can be adapted and used on an industrial scale to treat milk and milk products before they're available for consumption.
After this is selling milk. Milk is sent off in refrigerated trucks to the store to be sold. Enzymes used in dairy products. Some of these are food science applications that use enzymes to produce or make improvements in the quality of different foods. Each enzyme has a specific site of action on its target molecule and optimal conditions, example pH and temperature. First off is lipases, an enzyme that degrades fat. The major lipase in milk is a lipoprotein, lipase, associated with casein micelle. Agitation during processing allows the lipase to be in contact with the milk fat, resulting in fat degradation and off flavors. Pasteurization will inactivate the lipase in milk and increase the shelf life. Protease, enzymes that degrade proteins, and the major protease in milk is plasmid. Some proteases are inactivated by heat and some are not. Protein degradation can be undesirable and result in bitter off flavors, or may provide a desirable texture to cheese during ripening. Proteases are important in cheese manufacturing. Also, it makes yogurt creamier. Then there's lactase, an enzyme that breaks lactose into galactose and glucose. Without sufficient production of lactase enzyme in the small intestine, humans become lactose intolerant, resulting in discomfort, example cramps, gas, and diarrhea. This occurs in the digestive tract when ingesting milk products. Lactase is used commercially to prepare lactose-free products, particularly milk, for lactose intolerant people. It is also used in the preparation of ice cream to make a creamier and sweeter tasting product. Then there's lactoperoxidase, one of the most heat-stable enzymes found in milk. Lactoperoxidase, when combined with other chemical compounds, hydrogen peroxide and thiocyanate, it has antibacterial properties. As well, there's alkaline phosphatase, which is a heat-sensitive enzyme in milk that is used as an indicator of pasteurization. If milk is pasteurized properly, the enzyme is inactivated. And there's much more of these enzymes. These are just some main ones. The various ways which enzymes can be used in making dairy products is vast. Many are used in the production of cheese. The enzymes are what changes the characteristics of dairy, makes it creamier, changes taste, smell, and much more. Also allows some people to consume dairy due to the lactase enzyme. Overall, enzymes play a major role in the dairy industry, positively.